Hi, thanks everybody. I'm Dean Towsley. I'm a co-chair of the Water Quality Committee of Friends of Sligo Creek. Ann Vorse is my co-chair, and Christine Dunathan is our Salt Watch coordinator, webmaster, newsletter editor, all-purpose handy person. We're all going to talk about Friends of Sligo Creek's water quality program a little bit later, but first we have a guest speaker tonight from one of our most important water quality partners, Anacostia Riverkeeper, and that is Maureen Mitchell. We have several members of Friends of Sligo Creek who have participated in her testing program, and she's going to tell us about the results that have come from that for the entire watershed of the Anacostia, with a special focus on Sligo. So,
Yeah.
Maureen, it's all yours.
So, thank you guys so much for inviting me to be here. Obviously, I also have a very interesting part in Sligo Creek. I work for Anacostia Riverkeeper, but I myself am a Sligo Creek resident. So it's my home sub watershed. So it really has my heart. So I get to come here today and talk to you guys about the data we found this past summer and some of the concerning trends we're seeing. I'm really excited to have this opportunity. So if you go to the next slide, which is kind of previewing for us a little bit, just to remind you guys who Anacostia Riverkeeper are. I don't want to talk about this too much, but I do want to remind us that there's a lot of partnerships we do with Friends of Sligo Creek beyond this bacteria monitoring, where our goal is to protect, restore the Anacostia River for all who live and play in our watershed, and make sure we're advocating for those clean rivers and the communities living in it. So we're here today talking about our bacteria monitoring program. We also do a lot of work with trash and a lot of work with recreation and education. So a lot of these partnerships happen from FOSC. And if these are things you want to do, my email is on that first slide. Reach out anytime. Moving on to the next slide, Anacostia Riverkeeper, we know it's a large watershed in Sligo Creek. You can kind of see is just on top of the DC Maryland borderline as one of our sub watersheds. We initiated a citizen science-based recreational water quality monitoring in 2018. So I think that means we're about on year 8 of this program. Our program started in DC along the river. We're riverkeeper, so that's where the natural place for us to start was. But as we started recognizing these trends, we wanted to expand out into the tributaries to understand better, are those streams safe to splash in or not? So in 2020 was our first year of monitoring. We did start this partnership, started right with Friends of Sligo Creek. 2 of our sites were on Sligo Creek. We initiated our Maryland monitoring and excited to continue that program up today. We currently have 9 sites outside of DC in the tributaries. I want to say that most of them are in Montgomery County, as that is our best funded project. We love working with MoCo DEP and CBT on this grant. We also have amazing partners with Friends of Sligo Creek, Neighbors Northwest Branch, One Montgomery Green. Also want to make a quick point. This will be interesting towards the end of the presentation, that as of this year, we are officially a Tier 3 monitoring program at Anacostia Riverkeeper. That means that our data has met some standards within MDE, which allows us to have a little bit of regulatory and legal implications. So our data, we had to go through lab audits. Dean was actually the one who participated in our field audit this year. So special shout out to Friends of Sligo Creek for helping us with our auditing process. We had to submit a bunch of documents and do precision testing. But with this, our data is now regulatory quality, meaning that it can be used to list or delist watersheds with MDE's processes, but also that our data has met some standards. So if we ever wanted to use it in any legal actions, it would stand up in court. So as we start to talk about some things that are concerning, that means our data has a little bit more of an edge to it, which I think can be used to push for change. So going to that next slide, the monitoring program I'm talking to you guys about today is our recreational water quality monitoring. We run this May through September, the warm season where people might be putting their feet in streams. And the focus of this program is really talking to community members about, is the stream safe to splash or do any type of water contact recreation? Could talk about swimming down in DC and the river is big enough, but it's not quite legal in DC as of yet. We could talk about boating. We can talk about walking your dogs. We can talk about kids that are wading the river. And we want to make sure we're giving people data to know if that is a good decision at that time, at that location, or if it's not. The the parameters we look at for this are bacteria, pH, and turbidity. And so at that bottom, I think that's the bottom right hand of y'all's screen, you'll notice that we have some standards set. And these are standards that have been set by studies by the EPA that kind of we use as guidelines of when the river is safe, when the streams are safe, and when they're not. So for bacteria, we're talking about, I'm going to use NPN and CFU, most probable number of colony forming units. Basically, if I have that jar of bacteria that you'll see our samplers get for us, and I chugged it, how many colonies of coli would grow in my tummy? And for a healthy person, your immune system can fight off under 410, they determined by science I don't quite understand, but big studies in Chicago showed that 410 colony forming units of bacteria, plenty safe. A healthy person's immune system can suppress it. Above 410, that is where EPA says that is too much bacteria. If for any reason you ingested that, you are likely to become ill. We also do monitor for pH and turbidity. To be very honest, we never fail recreational standards for pH or turbidity, at least with the quality of devices we use. But we are looking for a nice moderate around 7 neutral pH. And turbidity, that really is talking about like how cloudy or dirty the water is, especially up here on Sligo Creek, where we still have relatively rocky bottom streams compared to the river, where it gets quite muddy. 20 NTU, nephelometric turbidity units. It's just if you shine a light through the water, how much of it's bouncing back. And again, under 20, we did not fail under 20. I think one time we had 18 on one Sligo site, but that was one of those horrible rain days that we know that can happen in. And so our goal is to talk about these standards. Do they meet the standards? And when not, we'll use colors, we'll use language to tell people that those places are not safe. So going on the next slide, I just talked about bacteria, and specifically we're talking about E. coli bacteria. That is a fecal bacteria. So anything that's warm-blooded, that E. coli is going to live in your intestines and help you digest that food. E. coli is great in your own intestines, but we don't want it anywhere else, and we don't want other people or organisms E. coli getting in us because that can get you quite sick. So I want us to start to think about E. coli and sources of that fecal contaminants, right? How is poop? Hate to say that word, but it's the simplest one. How is it getting in your water? And I start to think of it in two different buckets of different types of polluted E. coli high streams and how they're getting in there. One source of E. coli tends to be from stormwater, right? We know that we have dogs and sometimes owners that don't pick up after them. We have rats, we have birds, we have foxes. There's a fox living in my backyard. It's quite annoying me lately. We have all types of mammals and birds that are living in the water, that are living in our watershed, that are walking on our pavement. And so anytime it rains, that poop is going to get flushed into the stream. And so some sites are going to have really high counts of bacteria, especially after rain, because they're influenced heavily by stormwater. Those sites are ones that might be safe to swim in dry conditions if it hasn't rained recently. But anytime it rains, we see bacteria levels spike. The other kind of bucket of sources I want to talk about, unfortunately, is the human sourced E. coli. We make E. coli, and our E. coli it should go straight down those sanitary sewer systems, right to Blue Plains, be processed. However, we know that, unfortunately, those systems do not work right a lot of the time. And so we do have some sites that have these infrastructure type sources. These can be broken sewer lines, either major breaks that we hear about. And I know if you guys are on the listserv, you see Anne is helping alert us of those all the time. Those also can be minor breaks, smaller leaking that over time would add bacteria to the water, leading to those sites being high in all weather conditions. Whether it rained, didn't rain, that broken sewer line, that illicit connection, someone's house that they plugged it into the wrong place and they flushed right into the stream. In DC, we also talk about sewage overflows. The different types of sanitary sewer systems actually have ways that are built to overflow instead of flooding into your house, into the stream. And those sites, if they're by an infrastructure source, are going to be high in all weather conditions. And so we want to start to think about, if we're having high bacteria, is it a stormwater or is it an infrastructure source? Because that starts to tell us how we should combat this to eventually get swimmable and fishable streams and rivers. So if you go to the next slide, before I talk about Sligo Creek, I do want to zoom out a little bit and talk about really big picture trends that happen across the entire watershed. And this map is a little bit small, so I am really sorry about that. But if you'll follow down to that bottom right corner, that's right where the Anacostia River meets the Potomac. And the Anacostia River is tidal. And that tidal flush that happens twice a day actually cleans a lot of the bacteria out. That slight salinity, that constant flushing, that large water volume. If you wanted to go and touch the Anacostia watershed, that's where I would tell you to go. That's where I can confidently say that has the best water quality from a bacteria perspective. We know that this site right here is our AR6 site. That's at the Henson Center, right over the two Potomac and Anacostia come together. That only failed one time the entire summer. We do test weekly in DC, so that's only one out of 20 sites, 20 occasions where it failed. And plenty of those occasions were after heavy rain, and they would still fall below that 410 level. As you move up the river and you have smaller water volume and less tidal flush, you'll see that the green, the passing percentage on those pie charts, gets smaller and smaller. Once we get into those streams with a smaller volume of water, less dilution effect, if you will, but also getting a lot more influence of stormwater, we see that those streams have a lot higher bacteria levels. Again, we're losing the tidal flush. We are having a lot more stormwater. Hypothetically, and we start to see this at a couple of our sites in Prince George's County where we're actually sampling above the major urban areas, we actually will start to have a bounce back. There might actually be some really nice clean water, and some of these tributaries like Indian Creek and Paint Branch and Beaver Dam Creek, where you get well above the urban area and stormwater is no longer the large influence. That right now is hypothetical. I don't really have any sites up there, a couple grab samples here and there to tell me it's possible. But on Sligo Creek, unfortunately, the headwaters of Sligo Creek are still in a pretty urbanized area. And so we're not seeing that effect. You're in the stream, you're having stormwater influence, bacteria is high. If you go to the next slide, I kind of hinted at this a couple times. We talked about stormwater. We all know stormwater, it rains, a lot of pavement, a lot of impervious surfaces here in the Montgomery County area. So when it rains, all that water rushes into the streams, and streams will have a very, very quick spike of bacteria right after the rain. And I don't know how well these maps are showing up here, but I wanted to point out that we have these impervious surfaces, especially here in the kind of downtown Silver Spring area. We have lots of impervious surfaces along the Sligo Creek. And notice that all the places that are high in impervious surfaces also tend to be these places that are red, that are marked imperiled in Montgomery County studies. Rain flushes not just bacteria into those rivers, but sediments, nitrogen, phosphorus, PFAS, all the stuff that might be washed in there. So all these streams that are in these impervious surface areas are very stormwater impacted, and therefore are going to be, anytime it rains, getting large flushes of pollutants. And so anytime we think about recreation, if it's rained in the past 48 hours, stay far away from water, you, your kids, and your dog. So I'm starting to get closer to data for this year. If we'll go to the next slide, I want to set the stage, remind you guys where we sample along Sligo Creek and Long Branch. We actually have 6 sites, which I told you there's only about 12 sites in our tributaries. So we're giving these watersheds a lot of love because they're ones we know are imperiled and we know there's a lot of recreation happening. We have 4 sites on Sligo Creek. The farthest up one is at the Dennis Ave intersection. I'd love to add another one a little bit higher towards the headwaters. That's as far north as we go at the time. We then have 2 that are kind of paired right above Wayne Ave and right below Wayne Ave. So I call our above one our Schuyler Ave. And then Wayne Ave, that's right below Fleetwood Terrace School. If you guys are familiar with the area, we have those 2 sampling sites looking to see how the downtown Silver Spring drainage affects Sligo Creek. And then we do have one at Maple Ave in Tacoma Park, looking to see that's pretty close to when it starts meeting up with Long Branch and then moving on to Northwest Branch. We don't have anything in Prince George's County at the time. If anyone has any connections with funding sources in Prince George's County, I'd love to add more sites there. I'll add that we have 2 sites on Long Branch. We have one up right below Piney Branch Road. That's kind of our northernmost Long Branch one. That's where the stream is a little bit intermittent. We have a lot of pooling and a lot of stagnant water. And then we have one right close where it hits on Sligo Creek at Becca Lily Park. And looking historically at these sites, we start to see some trends develop. You'll notice here that I have 2 columns of data. These are average bacteria. One of these are in wet conditions. So anytime that in the 24 hours preceding that day, we had more than a ½ inch of rain. And you'll notice that, as I said, if it rained recently, remember 410 is our passing value. 410 is when it's safe to splash. And if it's rained recently, we are not splashing anywhere on the Sligo Creek watershed. Let's be very clear. You're seeing a little bit of variation up here at SE4. Those sites are really, really high. Again, headwater, stagnant water. Same thing at the top of Long Branch, stagnant, a lot of stormwater influences. Wet conditions, we are not splashing. But historically, and right now we're just looking at data from the past. So our first full season was 2021, 22, 23, 24. And dry conditions. That is the 2 days before sampling. It did not rain a bit, not an inch, not a drizzle, not a shower. We noticed that we have some sites on Sligo Creek that in dry conditions are splashable. These are averages. There's going to be some weirdness that happens. We'll notice that a lot of them are right around that passing mark. They're 300 to 500. So there are occasions when it's good. Sometimes it rained just like 72 hours before. So we're still seeing some stormwater clear. But we're noticing that on dry conditions, much of Sligo Creek, especially the kind of downstream, Maple's a little high. I'm kind of trying to figure out why Maple's high in that historical average. But what we find is as the water volume increases, you get further away from the headwaters. Dry conditions, Sligo Creek historically, not the worst place to splash. Not the best, not the worst. And notice that right down here, Becca Lily, LB2 is my shout out spot. That spot was one of our almost as low as Henson Center, right in that Anacostia tidal zone. Becca Lily must have some freshwater source nearby because in dry, non-rain conditions, double digits, a very safe place. If you see a kid splashing there in dry conditions, historically, maybe it's not the worst thing ever. But let's move on and talk about what happened this summer. So again, you'll see these pie charts here. We only sampled 10. I do try to avoid talking about passing percentages because they're so based on if it rained the 48 hours before. I don't know what happened this year. I don't know what weather god knew what about our sampling, but I swear every single Tuesday before monitoring, it rains. I'd have a dry stretch for like 10 days and day before monitoring, it would rain on us. So I will note that we did have a good amount of rain, but there also was that nice dry stretch in July, August. So we did have some dry sampling that did happen this season. And what I want us to start thinking about is remember what I said about types of sites and types of sources. If it is a stormwater site, you're going to have horrible high bacteria in the rain and splashable bacteria in the dry. This season, that was not the case. If you look here, same data board, just looking at the sampling that happened this summer. In the wet, that is rain in the 24 hours preceding sampling. Dry, no rain for 48 hours preceding sampling. We'll notice the trend no longer exists. There is a dip, right? The dry weeks are lower. The dry sampling occasions are lower than the wet sampling occasions. But on dry days, it is still nowhere close to passing. We're looking at double, almost triple that 410 passing, which is starting to tell me that I don't think we're having a stormwater problem more. We still have a stormwater problem because it is much, much higher when it does rain. But in dry conditions, there's still something feeding bacteria into our creeks, except for Becca Lily. Becca Lily is great, splash there and dry. We're still, that one is our holdout. But this season was really, really interesting in that what we saw historically just don't seem to be the same pattern. So going to that next slide, I think I kind of made my point this slide was supposed to make already, but I wanted to give you guys some time to think what is happening this summer that might be introducing bacteria, that might be changing. So again, we're noticing that in dry weather, Sligo Creek bacteria is very high when historically 4 years of data tell me that in dry weather, Sligo Creek's okay. What might happen? What might be causing this? I used to be a middle school teacher, so I'm always tempted to look for raising hands. I know we're in a webinar, so I'm not going to make you guys answer it, but I'm hoping some of the wheels are turning in your head. And if you'll go to the next slide, you'll see my hypothesis. Unfortunately, I don't have that flaming gun, amazing evidence to back up this yet. But I think looking at what we know about bacteria and sources, there's a shift happening. Sligo Creek historically was and still is very stormwater influenced. We saw the flooding this summer. We know stormwater majorly impacts Sligo Creek. And we do know that that stormwater can bring bacteria into our creek. However, I don't think we are solely a stormwater bacteria watershed anymore. Something is happening with infrastructure. Something is happening that is not caused by stormwater pushing things in, but rather something has been trickling bacteria into our stream all season long. And we really need to start working together to try to figure out what that source is and then fixing it. Because I'd love to go splash again. So I just have one more slide to start to think about what we can do. I don't want to leave anyone in doom and gloom. What can we do? We are noticing a trend. It is a worrisome trend, and this one is just a year-long trend. So we're not going to jump to massive conclusions, but the first thing we need is more data. We are working, we put together, actually was due today and submitted today, a proposal to Montgomery County DEP to expand some more monitoring sites alongside Sligo Creek, really doing some what I call transit sampling, where we're gonna go and at every intersection, we're gonna grab samples, hopefully starting to understand where geographically we start to see that spike occur and start to look at that land use and the outflows happening right in that region to see if we can figure out where that source might be. The other thing, which unfortunately with the government shutdown, I was hoping I would have ready for today's meeting, but we are partnering with Smithsonian, their Environmental Research Center, and there's a really amazing research from there that has been working with us all summer long to collect some extra water that will be used for something called microbial source tracking. Basically, not all E. coli is created equal. Some E. coli that was created in a human gut have a human genetic code, and E. coli that was created in a dog or a bird or a rat's gut are going to have a different genetic code. So we're going to start to look at just not the quantitative, how much bacteria, which is all I'm able to do with my lab, but we're going to look at the qualitative aspect of that bacteria. If we can point and say that this is human E. coli in our stream, that's the flaming gun we might need to make some people listen and force some changes to occur. As we said, this is legally quality of data. And so with that to throw around with the microbial source tracking, we have a powerful story to maybe force some change. Other things I want us all to do, make sure you're sharing this data. If you're walking down Sligo Creek and see someone splashing, find a way to politely tell them it's not the best idea, especially someone with kids. Dogs are also susceptible to different organisms, E. coli. So also, if you see someone letting their dog splash in there, that can not just be a source of coli, but their dog could get sick. We all love our pets, so let's avoid that. And then even though I did say that I was mostly concerned about this shift towards these human sources of E. coli, we do know stormwater is still a major issue in our watershed. So those of us who can advocate for some changes in green infrastructure, trying to control, to slow, to mitigate that, advocating for less pavement, more rain gardens, more green space, that can only help reduce the stormwater-linked bacteria, eventually leading to a splashable Sligo Creek. I hope I didn't take too much time or too little time. But Dean, that's what I have for you guys today. And if anyone has any quick questions, I'd love to listen, answer them now, but also I'm going to listen in and see how all of our stories, all our data come together.
Okay, thanks a lot, Maureen. Maybe we should plow through the Friends of Sligo Creek presentation and then do questions for everybody.
Works.
That's okay, so let me get our slides up. So some of this Maureen has already covered. Our stream is entirely urban. As she said, we don't have significant industries on it. We don't have significant agriculture on it, but we have lots of streets that wash into it, and that's everything on them ends up in the creek. The headwaters are up near Kemp Mill in Wheaton. At the eastern end of Blue Ridge Avenue, 3 culverts emerge close together, and that's actually the first daylight that the creek sees. It drains the downtown areas of Wheaton, Silver Spring, and Tacoma Park, and parts of Hyattsville and DC. And as Maureen showed us, it flows into Northwest Branch and then the Anacostia. So Friends of Sligo Creek's water quality monitoring program is not as ambitious as the one you just heard about. We tested 7 sites on the main stem of the river, plus 5 tributaries. two of which are stormwater outfall culverts that drain downtown Silver Spring. And just starting this year, our program has been qualified for inclusion in the Chesapeake Monitoring Cooperative's Data Explorer at Tier 1 or Tier 2 levels. And that system is a huge database of water quality that's used by state and federal agencies and NGOs in the Chesapeake Bay program. So the tests that we conduct are listed here: free and total chlorine, chloride, which is salt, nitrate and nitrite, phosphate, copper, and then physical characteristics, air and water temp, turbidities, specific conductance, which is another, some say more scientific way to measure salinity, and finally pH, whether it's acid or alkaline. And we test bacteria by a totally different means than the one Maureen just described, whereas her program tests 100 milligrams of water, which is the standard. Ours only tests 1 milligram on a little slide that gets incubated. So all of our numbers end with 2 zeros because I have to count the colonies on the slide and multiply by 100 to get the standard. The major issues that our testing shows are consistent with what Maureen told us about, E. coli, and the other one is salt. She didn't really talk about, but we're going to talk about a lot more. As she showed, E. coli is not always bad, but it can be bad anytime and any place in our watershed. And like her program so far, we can't distinguish between the sources, whether they're from human, canine, or wildlife. I'm going to give just a couple of samples of our data. The purpose of this slide is to show that a site that can be generally just fine, the first 4 months you see here, last winter from December through March, are all zeros. I counted no bacteria. In April, they started to appear again. Suddenly in September, through the roof. It was a perfectly dry day. It hadn't rained in at least 4 days when we tested on the 13th of September. Suddenly that site, which is just north of Colesville Road, it's near the first parking lot north of Colesville Road, was just crazy. Last month it was back down in the more normal range. This is typical of most of our sites on the main stem. They can be okay, and then all of a sudden they'll be terrible. We didn't get as consistently bad results. Oh, one difference I should mention, we do not test within 48 hours of significant rain. So we don't have any of that wet data that Maureen collects. So the whole first part of this summer, we didn't test on any of those days. The first 3 times we tested with Maureen, it was raining while we were testing. So the purpose of this slide is to show that at one of our tributaries, Brashears Run, which is just south of Maple Avenue in Tacoma Park, the water is not healthy hardly ever, and sometimes really awful. The next major issue we have with our water quality is salt, and that's particularly true during winter storms. And I'm going to turn over the presentation to Christine to talk about this. She's our Salt Watch coordinator. And I want to note that Salt Watch is a nationwide program of Isaac Walton League of America, and we're one of their major partners in it. So, Christine, it's up to you.
Thanks, Dean. Can everyone hear me? Yeah, good.
Yes.
So we have a pretty robust testing program of 28 people last winter, going out during and after storms, in some cases before storms, to test for salt using test strips provided by the Isaac Walton League of America very generously. And we had 2 teams, actually, a weekly testing team and a storm-related testing team that went out sometimes every day during extended bad weather. And we found that when we test right after a winter storm, surprisingly, the salt levels go up pretty quickly. And we found generally that the level of chloride in Sligo and its tributaries are quite high, well above, in fact, sometimes 6 or 8 times the chronic toxic level, and even well above the acutely toxic level of 860 milligrams per liter. This is in 2023-24 salting season, so not this last year, but the prior year. And what we found is that at all our sites in all our sections, we had just a big uptick in the amount of salt based on salting that occurred just before a storm. And we found that everyone who was testing got levels that were above 700. In this case, it looks about 750. And we realized milligrams per liter. And we realized that we were getting this shape of a graph because the test strips were topping out at 700, 750, and that we needed to have higher range test strips to accurately record what was happening. And so we had 2 major storms in this year, and this graph shows that, and that it took a while for the salt levels to get back down to the pre-season levels that you see on the lower left here. So this is what we found in 2024-25, and this is a very salty year, I must say. We had 4 storms. And the first couple were really major storms, and we saw the starting level of it was really under the 230 chronic toxicity levels, and within just a day of the storm, the first storm, which is represented by the first blue line, vertical blue line, we were getting test results that were on the high range test strips above 6,500, and in a couple of sites, above 6,000 in a few others, and the majority well above the acute toxicity level. And many of those sites stayed at those high levels or near those highest levels for a while, for about 10 days, actually a couple of them for a couple of weeks, and then slowly came back down. And then we had another storm, and etc. So this was really, really bad news for the creek and the critters that live in it, the birds that are hanging out during the winter, any mammals or other animals using the water. We were deeply troubled by this, and did write to a number of salting agencies like DOT and State Highway Administration and other agencies to ask them to tell them what we found, and to ask them to really try to adopt better salting practices. And we had a number of recommendations that we made. And so we're going to continue that this year. And I think we were encouraged by the response that we got from most of the people, most of the agencies that we talked to or wrote to. I wanted to show you this slide, which I'm going to share my screen. So this is a slide that takes the data and shows it dynamically. And I want to acknowledge and applaud the work of David Steigerwald, who David is a tester, testing at 3 different sites on Sligo, and he has some great Excel skills and data skills, and so he has put together this slide, this 3D model actually of the creeks and the levels of salt that we tested for. So this is when I start this. This is at the beginning of the season. These are the 28 different sites. several in Long Branch, several in Wheaton Branch, especially the stormwater ponds, and several along Tacoma Branch and right where Tacoma Branch meets Sligo Creek. So what this does is go through and show the daily levels when we tested for salt. So and they will light up like this one does. Green represents the amount of salt that is below the 230 milligrams per liter chronic level. Orange, of course, starts to creep up, and anything in the red gets to very high levels that are well over the acute toxicity level. So we start the season, a couple of places with some salt, but we haven't had a storm yet. The first storm is January 6th. Now we get a storm. Thing is quite red. So if something isn't lighting up, it's because we didn't test that particular day, but we may have tested the following day. So one thing you're seeing is that when there's a lot of salt cast, it affects the whole creek, top to bottom. As we come out of February, there is lower levels of salt. And instead of doing storm testing, we're just doing essentially weekly testing. And by the end of the traditional salt season, we're seeing levels that are a little bit lower than what there had been, quite a bit lower, and we're starting to get toward the green below the 230 chronic toxicity level. Some people very kindly continued to test just to see what would happen and whether it would get down to pre-winter salting season levels. And it did. It took a while. I'm not going to run this whole chart for that. So thank you so much, David. That was awesome.
That was very interesting.
Yeah.
I like,
So we can play it again if people want later, but I will stop sharing my screen just at this moment and continue on. So based on our results and on reports of excessive salt piles or excessive salting that people in the community reported to us and to the County 311 report a problem system, as well as expert guidance, we engaged parties at the state and local level. So that means DEP and DOT, Parks Department, DGS, and WSSC. We wrote letters and really took charge of this effort to other entities at the state and told them what we were seeing and that it was really excessive this year, and that while we knew that they are doing training and other things to try to adopt best practices, that they have a ways to go, and to ask them to tighten up and continue pressing for adoption of those better practices in practical application rather than in the overall plans and such, but really on the roads. We've posted all those advocacy letters on the FOSC website, and you can see those and see the responses of the agencies there. We ask people, of course, to request removal of excessive salt, and we urge them to sweep up salt for later use, but not to let it go into the storm drains if possible. It is, really tough to do. I think the people don't understand that oversalting does not increase safety, but it does really affect the environment. And so this county has expanded their salt removal activity to be year round so that if anyone sees, sometimes there are salt piles that last through the summer or into the summer, and the county will come and remove those through the 311 system. We think there's significant equipment failure, especially among contractors who get contracted by DOT and SHA to put out salt, and just a gap between what management would like and what is actually happening out in the field. Dean?
Thank you, Christine. Just a little bit about the other things we test for. Chlorine is usually not bad, but it can be high, especially if there's a water main break, because that's treated water that's getting dumped onto the street and then eventually into the stream. And for some reason, the two stormwater outfalls, Wayne and Bennington, that drain downtown Silver Spring, usually have higher chlorine than other sites we test. Turbidity is always high during storms and water main breaks especially. If a big pipe breaks, it scours the earth around the break, and that just washes down the street and into the creek. Phosphates and nitrates are occasionally high, and the sources of those are usually from fertilizers or surfactants like detergent. So I'm now going to turn it over to Ann, who's going to talk about our Water Watchdog program.
Thank you, Dean. Okay. I'm, in addition to being co-chair of the Water Quality Committee, I'm head of the Water Watchdog program, which is part of the Water Quality Committee. And I'm here tonight to answer the question, what's in the water, from the Water Watchdog perspective. And just briefly, a quick aside for those of you who don't know the Water Watchdog program, it's a system allowing anyone to report pollution in real time to the county. So if you see pollution in the creek or anywhere in our watershed, including on the street, you can report it by just sending an email and a photo to a special address. We'll have the information is on the slide, I think, in front of you. The report that you send, the email, goes to the county's DEP. They'll investigate, and hopefully they'll figure out who's causing it, stop the polluter, and fine them, which does happen. So to answer the question, what's in the water, the short answer from a water watchdog perspective is simply what gets in our storm drains or enters the creek directly. But the long answer is much more complicated, and it's full of surprises. Here are some water watchdog highlights. Sewage. We've heard a lot about sewage tonight. A private bus operator was caught siphoning sewage from his bus to a storm drain on Ellsworth with a hose. Another example, a porta potty tipped over in the wind and sewage ran into the nearest storm drain. I personally am convinced that we have not fully investigated the porta potty sewage Sligo Creek effect situation. We also see sewage when WSSC sanitary sewer pipes break. We had a break in downtown Silver Spring last night. We don't have information on it yet beyond that, but hopefully we will. Another surprise, toxic firefighting foam from practice in a parking lot. It went into the creek via a nearby storm drain. Grout from a metro tunnel work leaked and polluted one of our highest quality tributaries, Flora Lane. Dumpster juice. Dumpster leaks occur particularly visible in the alleys behind our shopping malls, and especially around restaurants. Kemp Mill, where our headwaters are, and downtown Silver Spring have been particularly hot spots there. Sediment from construction muddy runoff. There are many examples, residential, commercial, the purple line. Concrete slurry from street and curb construction. When DOT is tearing up a street to sink a new pipe or just to repair it, you have to make sure that they control the concrete slurry. Otherwise, it ends up in our creek. The dumping of construction materials, including paint, that's been a frequent report. Sediment, chlorinated water, temperature shocks, and flow intensity from WSSC water main breaks. floor stripping products, which went into the wrong drain in some schools. And then I'd like to add something in response to what Dean said a few minutes ago. It hasn't been a water watchdog report, but I'm wondering if the high chlorine levels are due to the fire department testing hydrants in the downtown area. I believe they're allowed to do so once a month, but that doesn't mean that they won't affect the chlorine reading. Maybe this is something we could look into a bit later. So how can you help? Please report pollution as soon as you spot it. Report it by sending an email to the Water Watchdog, report Sligo pollution at fosc.org. Add a picture or two. Put the location, date, time, and a brief description. If you see the likely cause, put that. You can do it as part of your daily activities. Just take 2 minutes. DEP will investigate. A photo is crucial so they can evaluate the situation immediately. And eventually, if we see enough of a pattern, we can target an area or a particular problem. So it's not just a one-off thing. Finally, learn about what pollutes the creek and try to change behavior. I know I've tried to do it, and it's kind of shocking the things that we're all used to doing but may pollute our creek. And that's all from the Water Watchdog Corner.
Thank you, Ann. So I want to briefly mention other programs. We've heard about Anacostia River Keepers. We've heard about the Salt Watch program that Isaac Walton League manages, and we're a major partner of. Nature Forward, which used to be called Audubon Naturalist Society, runs a benthic macroinvertebrate survey program that tests in the spring, summer, and fall at a location near the county line between Montgomery and Prince George's. And they tested sites on a number of other streams in the area, and Sligo is frequently one of the worst sites in terms of the biological survey, in terms of the numbers and the pollution tolerance of the critters we find that are clinging. It's mostly insect larvae clinging to rocks in the water. So most of the species we find in Sligo are pollution tolerant, an indicator of generally not great water quality. We have the USGS survey gauge near Maple Avenue that does continuous monitoring of flow, temperature, specific conductance, and other physical properties. Montgomery Parks does periodic electrofishing surveys where they stick electric probes in the water, and it shocks anything alive and makes them come to the surface. They collect those and do a really thorough survey of what's living in the water. A surprising number of eels, which they have to put into separate buckets because otherwise they'll eat the other fish. And finally, DEP in Montgomery County is our major partner for Water Watchdog. And they do periodic monitoring of their own. So I want to end our presentation with some positives. We have issues, but it's not as bad as it was in the past. When we first moved to our house in Tacoma Park in 1986, 3 blocks from the creek, most of the time when I went down there, I could smell it. It smelled like sewage. That is much, much less frequent now. There are lots of wildlife that depend on the creek, even though it's mostly wildlife that is pollution tolerant, but there's fish, turtles, salamanders, eels, snakes, obviously lots of other terrestrial animals, deer, raccoons also depend on the water. And finally, it's often a really beautiful stream, just a narrow strip in our urban developed area, but I find it to be an extremely valuable resource for forest bathing. This is just some general information about how you can get in touch with us. If you want to join any of our monitoring teams, either our monthly regular monitoring program or Salt Watch or the ARC program, let us know about that. And please do use the Water Watchdog program, report Sligo pollution at fosc.org. One of the great things about the cell phones that are ubiquitous in our culture today is that we're all carrying good cameras around and the ability to share what we find immediately. So that makes using the Water Watchdog thing pretty easy. So that's it. We are open for questions. And don't forget that you may be or likely are muted.
Well, I have a question to, first of all, I want to say how fantastic this is, pulling all this data, all these methods together. When I was president of Friends of Sligo Creek 2010 and 2013, our website offerings on water quality were nothing but dense charts of numbers. I had no idea what they meant. We kept adding them. We didn't have any talent on board that could effectively translate them into something people could understand, something that I could understand or the board could understand. It really seemed like a hopeless case, a mission impossible, but you all have made it intelligible and compelling. So that's really great. One thing I was wondering, since we have a very competent mapping resource now, which is what Christine was showing us, I wonder if there's a way to incorporate these one-off events into the timeline, either graphically or in a map, the things that Water Watchdogs discovers, and then you can plug in, okay, here's where this giant water main break took place. Here's the very next water quality result, and did it, what sort of effect, is it really visible? Is it really obvious that the sewage breaks or the construction crews doing the wrong thing or the fire department doing the wrong thing? It would be really great if somehow those could be incorporated as long as we have the talent. Is that possible?
I think that would be a great leap forward.
It wouldn't show causality. It would show concurrence, or we have to remember there's a certain base flow, and so concrete fines and other things get carried downstream relatively quickly, unless there's a big storm. So, it would be interesting, but we wouldn't be able to say too much, I think. We could see. I think I've also thought about doing just the number of events, sort of pollution events by location, and seeing whether there are certain super hot spots. We know of a few, and can speak to that, Bennington tributary draining downtown Silver Spring, and a couple others. And we certainly know where the salt hot spots are, at least as we were able to measure last year. And we'll see again this year whether those same sites end up being super hot spots.
When that huge water main break happened at Three Oaks this summer, I was so frustrated because the instrument that I use to measure turbidity and chlorine, which is a Lamotte colorimeter, was in the shop for calibration and refurbishment. And I really would have liked to get out there and see how much of an impact that had, because it was such a huge flow. It just washed so much sediment into the creek. But hopefully next time something like that happens, I'll be able to get out and do some testing just downstream and see what the impact is.
One thing that is, I know we're talking a lot of what we do, what Dean does, what I do is those grab samples, but there are some continuous monitoring devices in the stream that are interesting to look at. And that's what I would like to work with some of the stuff that Ann does, knowing when these events are occurring, trying to look to see if these continuous monitoring devices, we have the USGS station. I look at that sometimes. If I see Ann's report, I'll go there and see if the flow is spiked or not. But we also do have a partnership with the Smithsonian that does include some continuous monitoring, looking at like DOMs or dissolved organic material and FDOM and more nitrates and nitrogen. And so as they get their data, it'll be interesting to start to look to see how maybe taking in some of these events, see if that can register in these continuous monitoring devices.
I think it would be a great leap forward to try to link the various things that we know and to put it in some kind of put them in some kind of context, location as well. So I would love to move ahead on that. And there are a lot of directions it can take. And it's not certainly not causality, but it keeps pointing you in a more specific direction that can be really helpful.
Oh, one thing I wanted to add about salt that we didn't mention is the standards that we talked about, where a chronic toxicity of 230 milligrams and acute toxicity at 830 milligrams. Those are very old standards set by EPA, and many people consider them to be way too high. I think the state of Maryland thinks that chronic toxicity happens at 100 milligrams rather than 230. So, and some people think that the standard should be set even lower than that.
I've heard 50, at the conference we were just at last week. So,
Yeah.
I have a question about kind of the source of some of the dry water pollution and whether anyone's really investigated the Purple Line and the impact of the construction of the Purple Line. I always kind of note that the levels of E. coli below the Wayne Avenue construction site seem to always be high in dry weather events. And so has anyone investigated that and spoken to the Purple Line, because they've got money for mitigation and you want to make sure you get them on the hook before the Purple Line construction is over?
Yeah, that's a great question. That's exactly where my brain has been going this summer, watching the Purple Line construction while I try to sample. Unfortunately, what we have right now isn't the smoking gun we need to force a hand. But I have had a lot of conversations with the Montgomery County DEP. They're seeing the same patterns and they see what we do. The smoking gun is going to be that MST, the microbial source tracking. We have that Wayne Avenue. Those bottles are some version of being processed in Smithsonian right now. And unfortunately, with the shutdown, we're a little bit slower. We were hoping to have results in November. So I'm now assuming it'll be in January because they're 2 months behind. We also have a partnership with UMD, the School of Public Health. They're doing a different method, but also doing microbial source tracking, looking at things like antibiotic resistance that can kind of insinuate human. We need the proof. But DEP is working with us. DEP is funding us for this work. And so I think that give me 6 months and I think smoking gun will be there. Adding more sites, getting this qualitative data rather. It's coming. They just won't. We've had a lot of conversations with the Purple Line and with WSSC about these trends. And without the proof we need, they haven't been productive conversations, but it's coming soon.
I would note in response to that the Fleetwood site that we test every month is just about 80 yards downstream from Wayne Avenue and the Purple Line. And we have not seen unusually high turbidity or other problems there during the last couple of years, most of the time. And in one respect, the construction of the Purple Line has enabled major sewer rebuilds, storm sewer rebuilds along Wayne Avenue. And there's actually a brand new outfall into the creek at Wayne Avenue. The old one was one we've historically tested and was often horrible for bacteria. The new one has been very good. Now, I understand they actually built a big sand filter system in that before it gets to the creek. So it seems that is doing its job for now. Now, the question will be, do they maintain it the way it needs to be maintained so that it keeps working that well?
Sounds like great improvement for wet weather events, but it's the dry weather events that there be problems. And I just want to say, Maureen, thank you for all Anacostia River Keepers work. It's really, impressive what you guys are doing, and especially the new kind of tracking of specific pollutants. It's going to be a game changer. So thank you.
Yeah. Well, thank you guys. And we do it all with our partners. So Friends of Sligo Creek is right there in the weeds with us. I do want to know a quick question I'm noticing in the chat. Someone's asking about the bacteria testing. I'm assuming that might be a question for me. Our process is a 24-hour incubation. So if you add in I have to drive the samples to the incubator and process them. It usually takes me practically about 36 hours from scooping the water to getting the data out to the public. 24 is the strict incubation time, but 36 hours once you add in life's practicalities.
We have a question from Ellen and Bruce.
Wait, I'd like to add something before we leave the Purple Line and Wayne Avenue and Fleetwood questions. I don't want to push this unrealistically, but right around the area we're talking about is a huge fleet of porta potties, and there are also a number of them along Wayne Avenue, and last I looked along Sligo Creek Parkway right off of Wayne. And I've been trying to figure out, like, when are they emptied? When are they cleaned? How are they cleaned? And I was thinking there must be some kind of logging, some kind of record keeping. I don't know whether it's worth following up, but given the shocks I've had from some of these water watchdog reports where, a tipped over porta potty on Ellsworth DEP measured the E. coli. It was measurable, although it was small because of the small amount in the porta potty. But it it raised my awareness about how quickly these structures can have an effect. I don't know, what the routine for taking a hose and emptying them and so on is. I don't know enough about this, but it's on my radar screen.
I have seen, I'm in the neighborhood, just a block off of Wayne, 2 blocks, I guess, they diverge my street and Wayne, but I have seen big pumping trucks come by and presumably are leaving. They're going away from Wayne Avenue, but they are from the Purple Line contractor. And I believe they've just pumped out the porta potties. And so I think you're right. There must be some kind of log or some kind of service contract that says go every Tuesday and pump them out. So
Then
think
how
that's
do
a
they
great
clean
idea.
them? Then how do they clean them? We know with construction projects, at the end of the day, the guys do their cleanup and they wash things out and they send runoff into the creek. I mean, the porta potty, how are they cleaned? What happens to the...
Yeah, I don't think they clean them on site. I've seen other trucks with 20, 25 porta potties in them, and they swap them out, but they don't swap them out when they're full of stuff. They pump them and then they load them onto trucks. So they aren't cleaning them there, using water from wherever.
We had one in our driveway a couple years ago when we were doing a bathroom remodel, and they came every week and suctioned it out and then sprayed it and suctioned it out again. There wasn't any disinfecting that I could see except when they put fresh solution in it.
I do want to say that some of these levels are so consistently high that I wonder whether there are just colonies now that have been established and are thriving because of various conditions, warm water, low flow, that kind of stuff, and whether now these are just fixtures in the stream. And I don't know of any mitigation and what in the water quality world people do about it, if anything.
And I don't want to take up the question time, but that's something we've thought about a lot. We call those endemics. And a lot of times you can have outflows where these little stagnant puddles of water have these endemic colonies that then trickle, and they call it seeding the stream.
Mhm.
And so you can flush, there are ways if you discover it to flush it. And the MST source tracking will be able to differentiate endemic and active recently human. So
Great.
answers are coming, and I know there's other questions, so I can talk on another day about seeding and first flush and all these crazy phenomena I've learned about in the last couple of years doing this. But it's something that should be considered: is do we have endemic sources in our MS4 system? I think Ellen has a question. If you want to ask Ellen.
Thank you very much. First of all, wonderful presentation. Loving this. My question is, I've noticed in Europe, it is mostly Europe, there are new materials that are being used to replace salt, to just get salt out of that process. The most unusual and innovative one I saw was in a city in Norway using beet juice and cornmeal. And it served the function of making roads safe and feeding birds. So everyone was really thrilled with it. But I'm wondering if there is that active creativity as well. We know what we're dealing with. Are we also looking at broader solutions that keep us out of this salt trap? Because it really is, you don't want anyone dying on the roads, but you don't want everything dying in the creek either.
The county has used and the state have used a similar beet sugar solution with some bad results because it was not diluted properly and it made the roads very slippery and et cetera, et cetera. So that's been used. Yeah, that has been used in the States.
Never mind.
It's not that it's bad. It just, the devil's in the details and how it's applied. But I understand that that is not, different de-icing agents work best at different temperatures. And so there are temperature ranges that are good for one thing, for the use of one thing, and then don't become effective or stay effective as the temperature changes and conditions change. And so I am not an expert in this, but I have done a lot of reading, and I think there's some of that at play. I think we're in an area that differs significantly from Norway and from other places like Montreal or northern Minnesota, Wisconsin, et cetera, where once it freezes, it stays frozen for 5 or 6 months. Now, with climate change, that may be changing, but we have a climate here where it gets cold, it warms up, it thaws, it refreezes, there's more salt applied, there's more need for, an active desalting to take place. In Montreal, they've really, really reduced the amount of salt they use. They leave a base layer of thick snowfall, which turns to ice, and before it turns to ice, they put down a lot of small pieces of gravel. It doesn't ever reach the roadway to wreck the roadway, but it stays embedded as a source of traction, I guess you would say. And they don't go through this thawing and then freezing and et cetera, where that has to be, reapplied or somehow refreshed. So there's, I'm sure, lots of nuance that I'm not explaining, but I think there is the climate and the nature of the weather patterns and such play a role as well.
And some municipalities, including Tacoma Park, mix sand and salt. So the sand doesn't help melt ice or snow, but it does add traction, but probably also eventually leads to increased turbidity in the stream.
But I'm fully convinced, following up on what my two colleagues just said and Ellen asked about, that it's incumbent on us to go in search of best practices and see what's out there. And in fact, we wrote something to that effect among the many things that we recommended in our letters to the various state and local agencies. But one problem is also weather forecasting. It's gotten so tricky. One of the problems last year was, if you remember, all of a sudden we got a surprise storm, and then the next day it rained, and everything that had been put on the roads to keep people safe got washed into the creek. So the weather it's even more tricky.
Elaine.
Hey, so just wanted to say again, thank you to all of the water quality team for all of your hard work over the years. I know you all have worked very hard on all these different things. Shout out to Anne for the water watchdogs reporting on lots of things. And when we worked on the salt letter, we went around and around and around for getting it just right. So we needed your help with all that. And then also with Christine for doing all the salt data crunching, and for Dean for getting the CMC certifications, because that I think is huge. So I'm really glad that happened. And also to let you all know that David, who made the super fancy map, he answered the call because one of I can't remember for which thing, but I put out a call to volunteers that, there's something for everybody to do. You don't have to be the one going out and sampling the water. If you're good with spreadsheets, we've got a job for you. And he answered the call and said, hey, I can do that. And then he came up with that super cool map. So there is something for everybody. So thank you all for sharing your talents, whatever they may be.
And we couldn't do it without volunteers. At least I couldn't, managing the salt monitoring. It's just, it's a huge range. It's 10 miles or so of stream and different tributaries. And we're asking people to trek out in all kinds of weather. Of course, safety first, but it takes real dedication. And I was heartened to learn that many SALT volunteers are re-upping again this year. Last year didn't just completely
Yay.
kill any enthusiasm they had. So I think we can do, at least with SALT, we can do what we do because of our volunteers of whatever kind. And so we super, super appreciate it. And they're really wonderful.
I concur in that.
I also concur. Christine, my daughter's been asking if we're going to do salt again. So
Awesome.
up to you.
Okay.
So every time we walk by, she's like, Mom, is there salt in that water? So we're
Yeah,
going
buddy. Yeah.
to answer.
Well, we got several of our most egregious oversalting examples from near your testing area. So, yeah.
We'll be back. Yeah, thank you guys for this opportunity. And as I said, share the data, make sure everyone knows, and make sure people are splashing safely and salting safely. And we're gonna swim in Sligo Creek in a couple years. Okay.
So we have any more questions? All right, well, if there aren't any more questions, thank you all for joining us. I hope you found this useful, and we'll plan to do it again in the future.
Wait, there's one thing. Bruce put something in the chat. He has some good suggestions, and he's asked a question about, for salt, are there indicator species that are particularly sensitive? He's thinking of the macro problems with the creek. And I responded, I just wanted to draw this to everyone's attention, including Paul's. I said, good ideas, but ask Paul for number 3.
Well, and also we have our fundanas that have different macros and which ones are sensitive and kind of sensitive and then tolerant. So we have those available. And then Christine and I did the workshop in the summer, how to do the macro in resin. And so we learned how to do that. So hopefully we can play around with that sometime and make these things. Let's see. So hopefully we can play around with that sometime and then have those for show and tell too. So lots of ideas.
Basically, though, Bruce, Sligo on the index of biological integrity scores very poor to poor, and that is partly based on the macro testing results. Last spring, they were really bad, both in terms of diversity of critters and the number of critters. And you have one reading like that, you think, oh, it was a very cold week or something, and things haven't hatched yet. They're extra hidden under rocks, and we didn't dig deep enough, etc. But that continued into the summer. Low levels, low number of different species, and just low counts. And I don't think the fall data has been uploaded yet, so we don't know what the findings were. But we used to have higher numbers and greater diversity. We counted a couple of Asian clams. That's bad news. And Dean, you participated in the last testing, I think, right?
Yes. Yes, it was another one where about 3/4 of the critters we found were one species of pollution tolerant insect larva.
I mean, if we could find a single caddisfly, casing, that would be like huge news. And we haven't. So we'll see. I think, one reading can be, an off week or day, but as we look at trends, I think it's going to be telling. And so we'll see.
Bruce, I think in addition to the salt factor, we're underestimating the WSSC factor. Their water main breaks have been sedimenting the creek in really dramatic ways. And I don't think we fully understand the negative impact on the creek, but surely it's there. I think this is a huge issue, whether it's sediment or salt. WSSC is a huge salter. And we saw that last year in a couple spots in particular, and we could trace it like very directly to their salt management. But getting through to WSSC in and of itself as policy engagement matter is a challenge, shall I say, at the least. But I think it's an underappreciated issue for us.
Yeah, and we have had problems with chlorination, and the concern about chlorination is that if you have this one huge pulse that's come through, basically you're kind of killing a section of the creek acutely.
Yes.
So that's I know we've had that in different times for different water breaks before they get them under control.
Yep.
But so that's another WSSE thing.
Yeah.
Y-
Good.
Yeah, just it'd be interesting just to have a biological monitoring, not for our, I don't know that we're ever going to get it for our creek, but it'd be interesting to see if there's data already out there that shows which are the very most sensitive creatures and kind of keep an eye on those. Because we talk in generic form about where that this is a pollution tolerant thing. Well, pollution tolerance is obviously about a lot of different potential poisons. Not just salt. If it's just salt, that would be great. Then we can really focus on, not great, but it gives you something to focus on.
A specialized salt indicator species.
Yeah, exactly, right. Just sort of keep your focus. Anyway, yeah, by the way, with Michael, I'm very pleased with what's going on now. I was president at an even more ancient time than Michael. I think we were still using tablets of some, I mean, and I don't mean clay tablets, but it was like a very long time ago. And it's like I'm just so impressed that in less than 20 years, all this progress that we've made. So thank you, everybody who's contributing. And I know there's a lot of you.
On that note, I guess we can call it quits. Thank you again.